Hi, it's your math facilitator, Naomi Andrick. I wanted to do this example of a problem. This is one, it's right out of my math lab, where you're asked to solve the system by graphing, but then after you graph it, you find that the lines are the same line, and so there are infinitely many solutions, and the equations are dependent and consistent. But to walk you through that process, we're going to graph each equation. Now, these equations are in standard form, which means that I generally prefer, if the numbers work out fairly well, I prefer to use the x and y intercept in order to graph. Now, you could rearrange them, get them in slope-intercept form, and use that method to graph if that's your preference. But I find that it requires fewer steps to do the x and y intercept, so that's why I do it that way. So I'm going to do it that way. To find the x-intercept, of course, y is 0. So our new equation, we'd have 8x equals negative 20. And then if we solve that equation, we would get x equals negative 2.5, or negative 5 halves, or negative 2.5. Those are all the same thing. So negative 2.5 and 0, of course, because y is 0 for any x-intercept. The height of any point on the x-axis is 0. And then for the y-intercept, the x has to be 0 if it's on the y-axis. So we let the x be 0. We end up with, this is actually a slightly easier equation because negative 4 divides nice and evenly into negative 20. So then I just divide both sides by negative 4. A negative divided by a negative is always positive. So I'll end up with 0 for x, 5 for y. And so then from these 2 points, I can graph this line over here. So negative 2.5, 0 is right there. And then 0, 5 is right there. So that's the graph of the first line. Now, honestly, I see that this equation is going to be exactly the same if I just multiply both sides by negative 1. What do you know? It's the same equation. Its graph's going to be the same. But if we wanted to go through that process, or if you didn't see that, you had to go through the process again, you just go through it again. For the x-intercept, you let y be 0. You end up with negative 8x equals 20. And then after you divide both sides by negative 8, you get x is negative 2.5 again, and y is 0 because we let y be 0. For the y-intercept, we have to let x be 0. So if x is 0 here, we have 4y. I'll go ahead and write that equation. 4y equals 20. And then you just divide both sides to get y is 5. So x is 0, y is 5. Now these are exactly the same points that we got before, right? So if we go to graph this line, it should be in exactly the same spot. It's got all the same points, which means that any point on the line is going to make both equations true. So like 0, 5 makes this equation true, and also this equation true. But so does negative 2.50. And so do lots of other points. All these points on this line make both equations true. So as a result, there's not just one single solution to this system of equations. There are infinitely many solutions to this system of equations. So, infinitely many. And then consistent or inconsistent, we know consistent means it has a solution. Well, this has more than one solution, so it's definitely consistent. And then dependent or independent, if the lines are the same, they're said to be dependent. If they're not the same line, they're said to be independent. So these lines are the same, so this is a dependent system of equations. And that's all you do here. Now occasionally you'll get problems like this where the lines are parallel, they don't cross, and in the case that you graph two lines and they were parallel, then you would get, like, I'll just suppose I graph a line and it looks like this with the other one. They're parallel, they never cross. No solution, and independent and inconsistent because there's no solution. Okay, I hope this helps.